This is Rowdy with Rowdy Science. Today I'm talking about thin layer chromatography and how polarity relates to it. Let's get into it. Polarity plays an important role while interpreting your TLC results. Before I explain how it directly relates, let me give you a basic idea of what polarity is. Polarity is defined with how electrical charge / electrons are shared amongst atoms joined by a bond. For example, let's say that this gigachad is representing this chlorine atom, and this beta is representing this hydrogen atom. The bond, or sharing of electrons between them, is represented by this tug-of-war rope. You'd expect the gigachad to beat the beta in a bout of tug-of-war. Similarly, chlorine has a stronger influence on the electrons within the bond than hydrogen. So, chlorine is considered to have a partial negative charge, and hydrogen is considered to have a partial positive charge. The electrons are still shared amongst the two atoms, but at any one time, the electrons are more likely to be with the gigachad chlorine. Hydrochloric acid is considered to be a polar molecule. In another example, carbon tetrachloride is represented by these 4 gigachad chlorine pulling on this carbon atom in the middle. Even though the gigachad has a stronger pull on the electrons just between the carbon and the chlorine, all 4 of the gigachads pulling on the middle does not create any partial charge in the molecule, and carbon tetrachloride is a nonpolar molecule because of this. Lastly, polar compounds are attracted to other polar compounds, and nonpolar compounds are attracted to nonpolar compounds. The reason for this is beyond the scope of this video, but for TLC it is again important to remember that polar is attracted to polar, and nonpolar is attracted to nonpolar. In a TLC, you would not use simple molecules like hydrochloric acid and carbon tetrachloride, but I use them as an example for polarity. You may use examples like cysteine or phenylalanine, with cysteine being polar and phenylalanine being nonpolar. A TLC plate is made of a polar compound called silica. Since polar molecules are attracted to polar molecules, a more polar molecule like cysteine will be more attracted to the silica plate and will have a harder time moving up the plate while it's developing. Likewise, nonpolar molecules are less attracted to the silica plate, and the nonpolar molecule will move up the silica plate faster. In general, polar molecules move less up the plate compared to nonpolar molecules which move farther up the plate on silica. Lastly, the polarity of the solvent will also determine how a molecule / spot moves on a plate. More polar solvents will cause the spots to move farther up the TLC plate, as seen here, while less polar solvents will lead to less movement up the TLC plate, seen here. This was Rowdy Science. Hopefully this was helpful, talking about TLC and polarity. My next video will be talking about RF values with TLC. Stay tuned. See you later.